All right. So, yeah, thank you, everybody. Thank you for the nice introduction, and thank you for coming to my talk. I'm very excited to be here at AWE 2022. My name is Fabian Rücker. I'm from Fraunhofer IGD. We are based in Darmstadt in Germany. Just a few words about what is Fraunhofer. Fraunhofer Society is a society for research with institutes all over the world. And I'm from the institute called IGD, Institute for Computer Graphics Research. And we are working in my department for virtual and augmented reality, basically with VR and AR technologies, especially with computer vision. So yeah, a few words about my department. What we've done in the past is model-based tracking, as you can see here in this video. Basically, we have the CAD model of an object, and then we are able to track it frame by frame within a camera view, and then we are able to overlay it with additional information, or in this case, with the wheel itself. This can be used, for example, for overlaying repair instructions, as you can see here. So in order to show how, for example, the wheel is changed on a Porsche. Another use case would be quality assurance. So here you can see a production line, and it is automatically detected if everything is aligned correctly, those two components, as you can see here, or if they are aligned badly, as you can see here with the orange highlight. So this is the stuff we are working on in the field of computer vision. And there was a spin-off called Volumetric from our department who are specialized now on this model-based tracking. Right now, we are working on artificial intelligence-based object detection. As you can see here on the right-hand side, we are taking many virtual synthetic renderings of an object where we have the 3D model of this wheel, for example. And then in the next step, we are able to detect it in a single camera frame. So this is not tracking you're seeing on the right side now. It's based on just a single frame, an estimation of the pose of the object, of the wheel. I will talk a little bit more about that later. But today we want to talk about 4D streaming and, yeah, as it was mentioned before, remote assistance with social presence. So basically we have those 3 points you can see here. First of all, I will introduce you to the problem, then I'll show you the state-of-the-art solutions for this problem, and lastly I'll show you our vision and our approach to solve it. So first of all, the problem. Think of it this way. We have 3 clever engineers. They're coming up with a new machine another person is going to work on, and they're making the concept, and then they're building it, and after all, then there's the machine, and it's going to be located in some place in the world, for example, in Canada in this case. And some person is working on it. He's obviously a different person than the engineers who designed this complex machine. So as soon as there's a problem with this machine, the on-site worker has no idea what's going on because he has no idea about the inner workings of this machine. Therefore, he needs support from the person who built it and who made the concept, who is the remote expert in this case, but he is maybe sitting in another place in the world, for example, in Germany. And here's the solution, but the big problem is there's a huge way to go between Canada and Germany, and you can't just be there in an instant. So how can you solve this problem? First of all, the easy ones, obviously you can fly there and they both meet up in order to solve the problem. But this is time and cost intensive. Another solution would be just to go on a phone call and talk with each other. The problem can be depicted and the solution approaches could be discussed, but there is no visual feedback, and it's hard to see for the remote expert what's going on. Screen sharing is what we've heard before. Obviously, you can give better visual support because you're seeing the screen if it's, let's say, a software problem. But you can't work on the machine itself when you're sharing your PC screen, for example. That's why usually the remote assistance solution look as follows. Basically, the worker on site has a tablet in his hand, and this tablet view is sent streamed to the remote expert on the other side of the planet or wherever he is. And then the remote expert is able to make annotations on the screen, as you can see here. And this is transmitted back to the on-site worker, who is able to see what the remote expert just had drawn for him. I think we've seen that in a talk before as well. Also, here on the left-hand side, you can use, instead of a tablet, you can use AR glasses in order to have it within your field of view, not on this tablet device. There are a few values which are added by this technology or by this approach. First of all, you can highlight the specific points directly within the field of view of the user. You can set annotations in the field of view of the on-site user, and the remote expert sees exactly what's going on site. And when you're using an AR-HMD, also you have your hands free in order to work on the machine, or you could, in this case, you can mark no touch areas and what exactly there is to do. But there are a few shortcomings, and this is why we are working on this approach I've told you before. For example, here you can see on the left-hand side how it would actually look like. For example, the on-site user looks away, and suddenly the remote expert is not able to make annotations in the correct position anymore, and there needs to be some guidance. Please look a little more to the top, look a little more to the right. Those are some problems. Therefore, and also the tablet and the head need to be kept to some extent stationary in order to make good annotations as the remote expert. Those are the problems you are confronted with, and we think at Fraunhofer IGD that if you have a social presence right there with you, it's a more natural way to collaborate. First of all, we've made an extension of the state-of-the-art solution, though, as you can see on the right-hand side. In this video, on the right-hand side, the left side is for the view of the on-site user, and on the right-hand side, you will see the remote expert. And what's different here is that you see the environment is scanned on the go. So there's a gradual build-up of the mesh. Just imagine there's a texture as well on the right-hand side, and therefore the remote expert on the right-hand side is able to move independently from how the user on site is using his tablet around in order to scan the environment. Therefore, you can make annotations regardless of where the on-site user is looking at this very moment. And therefore, it's an easier way of collaborating. Also, you can see on the right-hand side that he's using a VR headset in order to see the environment in 3D. So, but now the topic of this talk is social presence in work environments and remote assistance. I want to present our vision. So keep in mind, this is just movie magic. We are not that far yet, but this is basically the idea. So the on-site user puts on his AR headset, and he calls the remote expert. This is my colleague Sarah. She could be sitting anywhere in the world. And then she's putting on her VR headset. And then she's displayed right in front of me within my field of view, within my experienced reality. And she, on the other hand, can see me as if I was standing there with her. Then we are able to collaborate. She's able to naturally show me, here are some screws, and also this wheel needs to be in a little bit of a different position. This is why I'm fixing it right here. And in our opinion, this is a more natural and more effective way of collaborating, especially on big machines in an industrial environment. So this is the vision. As I mentioned, it's movie magic. This is not what we are able to deliver right now. I'll get to that in a minute. But in order to achieve this vision, I'll show you 3 challenges ahead. So First of all, we need to capture the remote expert as he or she is. In this case, it was a she. Second of all, you need to capture the environment of the on-site user and also himself, so the person as well. And lastly, this is a little bit more technical, but I wanted to include it. You need a common coordinate frame. I will get to that. You will see as soon as I get to that slide. So first of all, we're starting with the remote expert. This is a rather easy one. So basically, you just put a depth camera in front of the remote expert, and then the remote expert is streamed to the on-site user, so he is able to see the remote expert in his AR headset. In this case, Sarah is streamed as a point cloud. The on-site setup is a little bit more difficult because we want to show the environment in 3D from different perspectives. Therefore, we need many different. We need multiple depth cameras, and in order, first of all, they need to be calibrated with regards to one another. Usually, we use a QR code. And therefore, each camera knows its correct position and orientation with regards to this QR code, and therefore, each camera knows where the other camera is exactly located. And therefore, you can make one point cloud of the whole environment. What this looks like in an early stage is what you can see here. So this is the live point cloud. You can also see the on-site user working on the brake wheel in this case. And yeah, this is what a point cloud might look like. You can also see there are some inconsistencies. It's not perfectly calibrated. That's when you see some parts a little bit doubled or with another shade, let's say. So lastly, the problem of aligning the two spaces. So basically what's happening, what I've presented you so far, we are capturing the on-site user and his work environment, and this is then streamed as a point cloud to the remote expert. He can either view it on his screen, or by using a VR headset, he can view it immersively. And now, as you can see, he's able to walk around in the point cloud, you could say, and point at specific points within the point cloud. But there's still a problem. Where do we put the AR, the AR version, so the point cloud of the remote expert within the perceived reality of the user who is on site? Because he obviously needs to be here and not at any place else. So in order to do this, basically what we need to do is, for example, we use another QR code, and then the AR headset knows where it's exactly placed with regards to that QR code, and the same applies to the VR headset, and therefore we know exactly where the user, where the user is with regards to the whole setup, and therefore you have a common play space where everybody is oriented in the same way. But of course, we don't want to use that many QR codes. It's just nothing nice. There's another technology we're working on at Fraunhofer, which can come into play here in order to calibrate the play spaces with regards to each other. We could use, instead of a QR code, we could use a 3D model which is detected, and then we know where exactly the camera or the VR or AR headset is with respect to that object. This is the video you've seen before. Basically, we are just training a neural network with synthetic renderings of a real object, and then in the next step, we are able to detect this real object in actual camera frames. Just very shortly, because I think I have the time for it, I can explain to you a little bit how we are doing it. So as I mentioned, first of all, we are doing the synthetic renderings. So our camera is taking pictures from multiple perspectives of the 3D model. In this case, it's a synthetic apple that we're having here. And then now I won't explain that into detail, but basically we are putting a filter, you could say, over those synthetic renderings. And then we are training with these augmented training data our neural network. And then as soon as we take a picture of the real object, we put some filters there as well, such that they look more similar to the training data. It's the so-called domain gap. And then as soon as we do this, the neural network is able to detect the apple and also to estimate its 6D pose, so position and orientation with regards to the camera. And lastly, obviously, you're then able to superimpose it with digital information. So how would this work? Basically, we take a look at this wheel, and we know exactly where the user is with regards to this brake wheel. And then we can align the two play spaces, and therefore the AR person, the remote expert, is positioned correctly within the reality of the person who is working on site. So before I get to the last video, here's just once more the setup. Here you can see the remote expert. She is, in this case, being recorded and captured by a Kinect, by the depth sensor. And then her point cloud is transferred to the on-site user, which is me. And I'm able to see her through my AR glasses, in this case a HoloLens. And then, on the other hand, my play space is detected by many depth sensors, and I myself am captured as well. And this is then seen by my colleague under the VR glasses. And this is the whole, let's say, loop, how everything works. So we are combining virtual and augmented reality technologies in order to achieve this. So this is, as I mentioned, it's a research project. We're still in research with this, but the idea is that you have basically you're able to work with somebody together as if you're standing next to each other. Here you can see me. I can see my colleague through the HoloLens. You will see the other view in a minute. And she's giving me instructions as to how to put the brake body onto the brake wheel. And this is exactly what I'm doing right now, since she's giving me the instructions. And as soon as I'm done, I look towards her and I say thank you and goodbye. Now, this is what it looks like for me under my glasses. This is what I experience when wearing the AR headset. So this is my colleague Sarah. She's being scanned by the depth camera, and she can point within my reality on specific points. And then I'm able to do whatever she's telling me to do, and we say goodbye. This is what's going on from her perspective. So I asked her for help. She puts on the VR headset, and yeah, this video is not that exciting. So basically, this is what she's doing. And lastly, this is what she's seeing under her VR glasses. So here we can wave to each other. And as you can see, things we are still working on is to get a more dense point cloud. Also, we are working on latency and frames per second, higher frames per second. But the difference to other approaches is that we have this social presence in this case. So lastly, as a conclusion, what we think is not being regarded with current solutions is the feeling of social presence. So right now, if you're taking a tablet or your AR glasses, you just see some annotations. But we think social presence is a huge factor for a natural collaboration and really being there with your colleague you want to work with together. And yeah, that's why we're working on this solution. And now I get to the end of my talk. If you have any questions, please just ask me right now after the talk. You can contact me with the data you can see right here. This QR code sends you to my LinkedIn. And yeah, thank you for your attention.
Let's give Fabian a big round of applause. Thank you so much. So, fascinating talk. I'm personally super, super interested in this, so I have some questions for you afterwards. But how about right now? Who has a question? Questions, comments? Is anyone else working with this? Yes. Just a second. I'm going to give you the microphone. Here we go.
Yeah, Fabian, thanks for this talk. It's pretty cool to see what's possible nowadays. I want to challenge you on the fundamental aspect. So, social presence is kind of cool, but in order to solve the problem, it's not really necessary, right? And it adds a lot of problems to your task. Am I right?
The last part of the question, why do you mean problem to the task?
I mean, implementing the social presence seems like to be very complicated. A lot of sensors, lot of stuff that needs to be implemented to make this possible. And in order to solve the problem, annotations and vocal guidance would be just enough, right? So what's the main benefit of the social presence despite feeling more natural?
Yeah, I think everybody has made the experience now that over Zoom and virtual meetings, many of the facts that make out our social behavior and working with each other is getting lost. At least that's my experience, and when I talk to other people. And additionally, the problems that I mentioned before, for example, letting the person, asking the on-site user to look at specific directions in order to make an annotation, that's a problem. And in our opinion, it's a huge benefit if you're just standing there right with him, and I can just look over and you're able to point at something. In the next step, we are also working on segmentation of the point cloud in order that the remote user is able to pick up some stuff, for example, the brake body, and then place it himself on the physical brake wheel. Obviously, the real brake body wouldn't move, but you can imagine that from the point of view of the on-site user, he would be able to see, okay, this like a ghost, it's moving there. So it would be easier for the remote assistant as well to work within the physically registered environment. Yeah.
Thank you.
Other questions or comments? And maybe you were just answering this, but do you mean that there would be virtual objects that the people would interact with, that the helpers would interact with in the future?
Yeah, yes, but not just virtual objects, also the real object. Obviously, you can't, as a remote user, you can't pick it up. But if you're able to segment the point cloud, you would able to pick up like a virtual clone of this object and put it somewhere else. So we're working on this as well.
Perfect. Thank you. Question?
Yeah, quick question on the depth cameras. How many are actually needed at this site where the work has been done to get proper kind of that 3D effect? Do you need 4 and one above, one below?
It always depends on what you're trying to capture. If you're just trying to capture a single person, you have the 3D effect right away with a single depth camera. But if you imagine there's the depth camera right here or here in front of me, nothing behind me would be scanned. So I would be seen in 3D. My hand is right behind my back right now. But in order to get me as a full person, I would need one in front of me and one behind me. And if you want to also capture the whole on-site machine, it basically depends on how big the environment is you would like to capture.
Okay. And the second question is, I suppose, as these headsets evolve and time of flight actually gets integrated into those headsets, do you see that they can be used, or is it because your head is moving all the time, it just be too difficult?
Could you rephrase the question,
please? Time of flight cameras are going to be integrated into headsets.
Yes, so you have 3D vision with the headset itself.
And can you use that information to make more realistic pictures?
I'm not sure if this would be of help. Possibly it could be helpful if there is a very good depth sensor installed into the AR headset in order to get a more dense point cloud wherever the on-site user is looking at this very moment. So if you would bring this together with the fixed setup of the other cameras, it could be an addition. But in my opinion, if you have a fixed setup with multiple cameras, they are probably more precise than whatever is built in your AR headset. But on the other hand, if you occlude something by leaning over it, you could definitely make with the depth sensor in your AR headset, make this include this part in the point cloud as well.
Great.
Thanks.
And I guess we've seen time-of-flight sensors being used for proximity sensing in things like the automotive industry and stuff like that when you're trying to put together an engine and figure out where a part goes and all that sort of thing. So I think there's definitely some crossover between having a helper there and doing it yourself, right?
Yeah, yeah.
Perfect. Well, let's give another round of applause. Thank you so much, Fabian, for today.
Thank you.